All right, we will get this going. Thank you for attending the East Bay Agile Stream QA Meetup Group. We are lucky to have Gene Gotimer present Testing in a Continuous Delivery Pipeline, Faster, Better, Cheaper. And now I will hand it off to you, Gene.
All right, thanks a lot, Mike. So thanks for the opportunity to speak today. My name is Gene Gotimer. I'm a senior architect with Coveros. We're a consulting company on the East Coast, and I'm going to talk today about developing your delivery pipeline. Specifically, I'm going to talk about different places to put different types of tests when you're laying out your pipeline, whether it's a continuous delivery pipeline, or hopefully this all still applies even if you're doing mostly manual stuff and still not quite to the point where you have tons of automation. All right, so first let me talk a little bit about Coveros. We're a consulting company. We do a lot of Agile and DevOps transformations, training, development, and we're really built on that security and Agile went very well together. That the easiest way to build quality software was to build security and quality in from the beginning and not try to tack it on to the end, and Agile just seemed like a perfect fit. We do a lot of a mix of government clients and commercial clients all over the place. So, all right. So, like I said, I'm a developer. I'm generally a Java architect right now, but I do a lot of training, do a lot of Agile, do a lot of security and DevOps. And one thing that we do on every project, regardless of whether you think about it or plan on it, is every project doing software delivery has a delivery pipeline. It doesn't have to be automated. More automated is better, but you have a delivery pipeline anyway. And that delivery pipeline is simply the process of taking a code change from developers and getting it deployed into production and delivered to the customer. For whatever process you use to do that, that's your delivery pipeline. Now, it has a lot more importance to be specified when we're doing automation and trying to get to continuous delivery, which is why it comes up so often in conjunction with DevOps and continuous delivery. But you have it anyway, and it's just, like I said, just the process. And we're going to break it up into stages along the way, not really phases or anything, just where we're putting the focus, with the idea that in the beginning, we're starting out with quick feedback, and as we move to later stages, we're trying to get to higher confidence, that we're closer, then get closer to production. And really what we're trying to do is answer this question. Do we have a viable candidate for production? Or at least, do we have confidence that we have a viable candidate for production, right? We're trying to start out with code changes that the developers make, and we're trying to push it through our sets of tests and checks and verifications all the way through to the point where we say, you know what, this is something I want to put into production, right? We've either hit the date, we've hit the feature set, we've just gotten to that level of confidence, depending on what stage of DevOps or continuous delivery you might be in. We're going to make a decision at some point that this software that we have here, that we have tested, that we've built up, and that we've checked, we are confident that this is ready for production, so that's where we want to put it, right? So if that's the question we're trying to ask, right, what does it really look like? Well, this is a conceptual view of it. This is not prescriptive. This is not a goal to match this, but just an idea of, you might start over on the top left, right? It's the beginning of your pipeline, where you have your requirements, you start doing coding, and then you check things in. And as soon as you check things in, we call that a trigger. Stuff happens at that point. Again, most of the time we're talking about doing this, it could be automated, but it doesn't have to be. All this still works, right? We check something in, and from that, we're going to go ahead and we're going to kick off some unit tests, right? So the trigger is the check-in, and then the quality gate that we're going to do is we're going to see, does this pass unit tests? And there's some other types of things we might do in here, and we'll talk about those a little bit later. But eventually, we'll feel that we've done enough with that, and we're going to deploy it to some sort of test system, and then we're going to run maybe functional tests, right? And if those look good, maybe we'll deploy it to another system. Maybe that's called staging. And if that looks good, we're going to get into doing something in pre-prod. Maybe we're going to do some sets of performance and security testing in parallel or something like that, and eventually we deploy it to prod. But the whole point is here, we're going to start with requirements and code, and we're going to move through a series of triggers and quality gates to more and more expensive tests. And those tests, or those quality gates, they're more expensive in terms of resources, they're more expensive in terms of people, in terms of time. They may even actually cost you some money as you get into doing stuff in the cloud and having to bring up certain types of hardware or systems or outsource work. But the point is, towards the beginning, we're looking at quick response. Towards the end, we're looking at more expensive quality gates. And what we're really looking to do when we try to develop our pipeline is try to lay out the things in the order that's best suited for us, right? The things that are going to give us the most efficiency, they're going to make us the most effective, that are going to give us the quickest time from I'm starting with the code change to the point where I say I am confident that this is a viable candidate for production. And the way we're generally going to do that is by starting with the stuff that's going to give us the quickest feedback, right? But that's not going to be good enough just to have rapid feedback early on, right? Because some of the things are going to take longer, and we don't want surprises at the end. That's really our goal. We want to start with rapid feedback and work our way towards no surprises, right? And that's really the goal. The goal of developing our pipeline here is to balance that. The early rapid feedback, where we're going to get quick feedback cycles, where we're going to know right away if things are working or not. And by the end, we want to end up with no surprise at the end that we're running these more expensive tests, but we have full confidence that they're going to pass, right? Now, you're not going to be able to do that if the first time you do any type of testing is at the end, right? So part of the goal was say, okay, let's move everything up first, but everything can't be first, right? For one thing, it would be a waste. For another thing, you have to do some things in some order. So what we're going to try to do is this. Do just enough of each type of testing early in the pipeline to determine if further testing is justified. If we do just a little bit of each type along the way, whenever we get to the point that we say, you know what, I'd really like to know how we're doing on security. Great. We do a little bit then, just enough to say, you know what, I think we're okay on security. There's no obvious low-hanging fruit. There's no obvious problems we've introduced. We're going to have to do a full security test at the end, but I'm pretty confident when we get there, we're not going to have any surprises, right? So maybe then we'll do a little bit of performance testing or manual testing or UX testing or focus groups, whatever it is, right? Do just enough of each type of testing early in the pipeline to determine if further testing is justified. So let's actually get into how we're going to do that and how that's going to work, all right? We're going to start by defining our delivery pipeline by doing a value stream exercise. Now, if you guys have a pen and paper handy or can pull up Notepad or something, just jot down some notes here. This would be a good time if you want to follow along. List out the steps that you normally go through to get code from a developer into production. Just all the steps that have to happen, all the things that are going to go on in order for you to get it through that system. This picture that's here, this is part of a course we give in DevOps. This is actually from the course. We had a bunch of input from a bunch of different people in the class, and this was kind of an amalgamation of all the different steps that they had to go through. We kind of combined them all into one representative flow. But this is the delivery pipeline, right? Whether it's manual or automated, the steps you have to go through when you start a code and then ends with deploys to production, that's your pipeline. And one thing we like to do in this, when we're going through this value stream exercise, is to identify the time we spend on each step. And there's two types of time that we normally have to look at. How much time does it take to do each of the steps? And how much time do we spend waiting? Right? Anytime we spend waiting, because we need a team to do it, we need an environment to do it, that helps us know that, hey, there's a bottleneck there that we could eliminate maybe with automation or with automatic deployments or something like that. Right? Anything that takes a long time because of execution time, it may be a good indication that, hey, this is something we want to move further down the pipeline, because the further down we can do it, the more things with rapid feedback we can get up towards the top. And again, we're going to try to do just a little bit of every type of testing early on, or earlier in the pipeline, so that by the time we get to the end, we don't have surprises. So it's not going to mean pushing all the slow tests to the end and then ignoring those types of tests until the very end. We need to do a little bit of everything. So let's talk about that some. Again, if you spend some time, just jot some notes on one of the steps and how much time you're spending, and think about it. That's going to help you start identifying some bottlenecks and what's going to be automated. Okay? And I'm going to break this down into 3 stages, right? They're not hard and fast. We don't hit a wall and say, okay, we're done with that stage, on to the next one, right? They're just kind of steps we go through where we're changing what we're focusing on. When we start making our code changes, our focus is going to be code focused. We're going to look, it's going to be developer centric, right? We're going to look at what's the code doing, how good is the quality of the code, do we have unit tests around it, that type of thing. And then gradually we're going to move into quality focused, right? How is this application running? Is everything working the way it's supposed to? Are we meeting the needs, right? And at some point you're going to get to a level of confidence that you say, you know what, I'm ready to put this out in production, let's get that stuff wrapped up. And then you really move on to something that's delivery focused. And like I said, this isn't hard and fast. It's just a gradual change in focus. We're going to go from being focused on the code we're writing, then we're going to start focusing more in the middle, which is really the big section in it, where we're focusing on the quality of the application that we've created, the systems we've created. And we're going to finish up with, how are we doing on delivery? Can we focus on getting this delivered? What things do we need to do right at the end to make sure that delivery is successful? All right, so laid out back with that same example flow I showed earlier for the delivery pipeline, the commit stage, right? Code focused, it's developer centric, right? This is rapid feedback. We want in 10 minutes to know how is the code looking. We want just a quick set of tests with a 10-minute maximum feedback loop there, where I check in code and I know right away what quality it is. It's passing unit tests, static analysis, that type of thing. Why 10 minutes? Well, because we want the developers at this point to be waiting, right? This is so early and so rapid feedback. If anything goes wrong here, I'm going to hold up other people. So what I really like to do is have the developers wait until all of this is done. It's only 10 minutes. They can afford to sit there and wait. And once it's done, once they're done seeing if everything passed, everything gets green, then it moves into the next phase, or next stage rather, then they can go on. They can go get their cup of coffee and go talk to a colleague. They can start the next task they're working on, whatever that case is, right? But that's the commit stage. And this corresponds really closely to continuous integration. So if you're doing continuous integration, right, 10 minutes maximum, that's really kind of what you're looking for. I check in code, it automatically runs the unit tests, runs some static analysis tools, maybe packages it up ready to be deployed to the first environment. 10 minutes, I know it's good, I can go back and start the next thing and we move on to the next stage. All right. Actually, can we do a show of hands? Yeah, let's do a show of hands. Let's see how many people are using continuous integration now. Can we do that? It doesn't look like it's working. All right. Anyway, so like I said, continuous integration, that would be this step, this commit stage. All right. The next stage, right, we're no longer code focused. We're going to move on to a stage that's acceptance, right, quality focused. And we're just trying to do all the types of tests that we might do, all the types of checks and verifications we might do to decide, is this a viable candidate for production? Now, one of the things I don't like about the way I drew this pipeline out is that I did kind of divide it into 3 about equal stages, and that's not really accurate because the first stage, like we said, is about 10 minutes. This acceptance stage, this is the bulk of what you're doing. This is all the tests you're running, all the time that the QA folks are working on it, all the time that the product managers are looking at it and making sure they can accept it. This is where almost everything happens. Everything that happens until the point where someone says, you know what, I want this in production. Okay, I'm confident that we have a viable candidate for production. I'm confident that we're not going to have any surprises. Everything from the code checked in to, or the unit test passed to that is the acceptance stage. All right. Now, it's important to know that during this pipeline, this isn't single-threaded in that when we get to this, the developers have gone back to work. We're not at the point now where the developers have just stopped waiting for the acceptance change then. They went back to work, right? They haven't stopped. They just went on to the next thing. They're going to start something else flowing through this pipeline. So you may find that a lot of things flowing through the pipeline at once, right? Especially when you get into automation and dynamic environments, you can do a lot with parallel development and things flowing through and being at different parts, different stages in the pipeline at the same time. Okay? The last stage is the end game, right? This is where we go from quality focused to delivery focused, right? We are confident at this point that we have a viable candidate for production, and we're confident that we don't have, that we're not expecting surprises. We've done enough of whatever types of tests we need to be sure that, hey, you know what, I'm going to run these last sets of tests, but they're going to pass. I'm pretty confident of that. So let's start doing the things that we only need to, that we only get done once in a while, the things that only happen when we're getting ready to release. Okay, so these are going to be the more expensive stuff and the stuff that only happens once in a while, right? The packaging, marketing, documentation, non-development type stuff that goes along with putting out a release. It could be the expensive tests, whether we're sending some stuff out to the cloud to be tested, we actually need to pay for some environments, whether we need to do some manual that just takes a long time, the official security tests, the stuff that people say, hey, this is mandated, you need to do this, we need to send it to the security team, so we're going to give them a 3-day window where they're going to do it. It's only going to take them a couple hours, but we need to provide the system to them for a couple hours, and we can't do anything on the system while that's happening. All of that's the end game. It's the stuff we don't want to do. We don't want to hold everything up and slow down our feedback cycles or spend money on or spend time and resources on, but it is stuff that needs to get done by the end. But again, we don't want surprises. So if I go back here, like I said, code focused in the commit stage, quality focused in the acceptance stage, and then we have the end game, delivery focused, right? So let's take a look. If you were to start with that value stream, right, the list of steps you went through and kind of split them out, you might want to put them into these acceptance stage, end game. So commit stage might be something like we're going to start by compiling the code, we're going to run our unit tests, then we're going to do our static analysis, right? After that, we're pretty confident that the a measurable list, state of quality that we can hand it off to a test group or start doing the automated testing or start doing some real testing on it. What we have here is not code problems or you know, that it won't compile or the unit test won't run. Now we're actually getting into, let's start looking at the quality of the system we're building. So that's good stuff like functional tests, regression tests, acceptance tests, right? All or some of which may be automated. We're going to do our system integration test, and we're going to bring up all our systems. We're going to talk to other systems out there in our network there, in our overall system, right? Once we get through kind of all these types of tests, then we're going to move on to the end game, right? We're going to do the things that we save to the end. Security testing, performance testing are traditionally done late in the game because of the expense and the time they take, and sometimes they require specialized teams, specialized skills, specialized tools, right? We'll do some exploratory testing, the manual testing there. Maybe our usability testing happens in the end game, right? Because it requires focus groups, it requires people who are experts in watching what's going on and evaluating the testing, and the things, like I said, the non-developer stuff, the packaging, doing printed documentation, doing a release announcement, right? But when I look at this, there's a couple here that are real problems for me, right? Packaging, printed documentation, release announcement in the end game, they have to be at the end. That's because I'm actually putting out the release. But these other types of testing, they worry me. I haven't done any of those types of tests in the acceptance stage. So I really want to get something in so that I'm not getting surprised when I do the first of these types of tests. So what I want to do is try to move them, right? Can I move those to the acceptance stage? Well, that's a problem because they're fairly expensive and I can't do my full test there. That's why I had them in the end stage in the first place. But maybe what I want is really something that looks kind of like this. I want to do some security testing. I want to take a look at my performance trending. I want to do some early exploratory testing, just quick time box, something easy. Does everything look good? Just have somebody take a quick sanity check and poke around for a few minutes while other things are going on. Maybe I want to do some basic usability testing, right? And then for the end game, I can save the mandated security test, the one that I have to ship off to the other group, the one that has to meet certain needs, has to use certain tools, right? But I've already done some security testing at that point, so I'm less likely to get any surprises, right? My full load and performance test might have to wait to the end. But if I've done, take a look at my trend and notice, hey, I'm getting a little bit faster, I'm not getting any slower, well, my last load and performance test, this should just be a double check that, hey, nothing slipped by, but we're probably going to run about the same speed we did last time, right, or a little bit faster, or whatever the case may be. We're going to do some continuing exploratory testing, right? Maybe we have a bigger team do it rather than 1 or 2 people. Maybe we actually do our focus group at the end game. But if I've done some basic usability testing, I know I'm not going to crash and burn immediately upon entering that room, and I'm not going to waste my whole team's time. Right? So that's kind of the goal here, is to do that balance, move some stuff around and figure out where we can do different types of tests. So let's take a look, and again, the goal, do just enough testing to determine if further testing is justified. Early in the pipeline, we gain confidence that we're not going to get any surprises. Late in the pipeline, we might finish it up, but again, no surprises, we have confidence, we've already done some of every type of test. So here's an example, right? Let's say we do performance testing as part of our current pipeline. We do a full load and performance test. We do it in a dedicated environment, no other traffic running on it. Nothing's going to taint the speed, taint the throughput, right? We're using production-sized servers. They're a little bit expensive, but you know, hey, it's the end of the thing. We want to make sure everything's working. We want to get some complete feedback here. We want to have confidence that we are doing everything right, and we want to know what our sustained capacity and throughput is, right? We're going to do, let's say it's going to be 4 hours. We're going to do 1,000 concurrent users. We're going to burn this in, wait till it ramps up. We're going to do this full-blown test and really see, are we going to support the traffic we're expecting? We're getting ready for the sales season, right? We're getting ready for a big push, a big marketing push. We need to know we can support this, right? That's our full-blown test, right? So maybe earlier on, we want to do something else. Maybe earlier in the pipeline, we can afford to do a short JMeter test, right? JMeter is a freeware, or an open source product. It's written in Java, but it doesn't really have anything to do with testing Java applications in particular. It's something we could run on a development system. We might do it with no isolation, right? So yeah, if a couple builds are going on at the same time, or if it's just a lot of network traffic at the time, maybe it runs a little bit slower, but maybe what we want to do is just do something that's like a 5-minute test, right? 10 concurrent users for 1,000 requests. How long does it take? Does it take longer than last time? Did it go shorter than last time? Did it take about the same amount of time, right? Just give me an idea. Am I doing about the way I was doing before, right? Just track the trend and see, are we getting slower? Are we getting faster? Are we staying about the same? It doesn't answer the same question that the load and performance test does, but it does give us confidence that by the time we get to the end, we are not going to see any surprises in that load and performance test. Okay. Another example would be, say, security testing. Let's say that we are in an environment, maybe it's regulated or maybe it's just our policies say that we have to do an HP Web Inspect application security scan before we can put something into production. That's our corporate policy. And we have a corporate security group that has to do that scan, right? They have the tool, they have the expertise, they know how it works and how to read it. It's going to look for black box web vulnerabilities, and it's going to answer, do we have any cross-site scripting vulnerabilities? Do we have any cross-site request forgeries? Do we have any SQL injection, right? Do we have any web vulnerabilities that somebody could exploit remotely? That's what we're trying to answer by running this scan in the first place, right? But we need the team to do it. We need them to sign off and give us the thumbs up that says we are good to go. All right? Maybe the other thing they have to do is scan the system itself, not just our application, our web app that we're deploying or whatever it is. Maybe they also have to do a Nessus scan. That's our corporate policy. Again, we have a security group that does it. Looks for the open network ports. It looks for software with CVEs, with known vulnerabilities. Common vulnerability enumeration is what CVE stands for. And we're trying to see, is our system compliant? Are we in compliant with all the security policies and stances that we want to take, right? So that's what we're doing at the end. But again, can we do anything earlier on that might give us that confidence before we have to waste time doing these, right? So here are a couple ideas, right? Whereas with performance, we were answering a slightly different question just to give us a little bit of confidence. Here, maybe we can actually look at the same types of problems, right? Instead of using Web Inspect, I could use OWASP Zap, which is an open source product by the OWASP group. You can download it. Again, it's a Java project, but it does not require a Java app to be tested. You can do this during early testing. And to be honest, with OWASP Zap, it's called a passive proxy. It's a way of running traffic through it, and it just watches traffic, the request going out, and the response is coming back. That could be used alongside your existing functional tests, your regression tests. If you just pipe them through that, right? If you're using, let's say, Selenium to do your testing, pipe them through OWASP Zap, and you can get to see, do we have any cross-site scripting vulnerabilities? Do we have any cross-site request forgeries? Do we have any SQL injection problems in the traffic you're seeing going back and forth? Right? We're answering the same question that they're going to answer with Web Inspect. So I know if I have a good enough coverage there, I can gain enough confidence to know that I am not going to have any surprises by the time I get to the official scan, the mandated scan by the corporate security group. Also, Nessus is a commercial product, but long ago it was an open source project, and it split into two. There was a fork, an open source fork called OpenVAS, Vulnerability Assessment Scanning. That's something we could run locally, right? We can run in our test environment. We can look for open ports. We can look for software CVEs, and we're really answering the same question. We're finding out here, is Nessus likely to find anything? Right? Now that gives us a lot of advantages if we can start answering some of these questions early. In the case of security, if we have remediations, rather than finding out the end where we'd have to remediate right when everyone's breathing down our neck saying, get this release out, here we can say, look, it's just part of our normal test cycle. I have time to update the version of Java. I have time to update some of the software that's on the box. There's the version of OpenSSL, the version of OpenSSH, whatever's running on my system, right? And I can address those through open source products, freeware products, easy to acquire products, easy to use products. And yeah, maybe it's not as complete as the scans I'm going to do at the end. Maybe I don't have the same level of expertise that the teams at the end are going to do. Same thing goes for performance testing. Maybe I don't have the same expertise or the same isolation that I was going to get in the load and performance testing at the end, but at least I can get some idea. How is this going to go? Am I likely to experience any surprises, right? And why do we want that? Again, quicker feedback cycles are better. It's easier to make changes. It's easier to react proactively if we know the stuff sooner rather than later. Most people have probably seen this graph in particular by Scott Ambler, or a graph like it. It's talking about cost versus the length of feedback cycle. And you see the stuff in green is the stuff closest to the axis there, right? The stuff we find earlier. Those are things that are cheaper to fix, right? There's no hard and fast break there, but you can see early on, right, if you find something in pair programming, continuous integration, TDD, active stakeholder participation, meaning something we find during the sprint if we're doing Scrum, the stuff we find early on is fairly easy to fix. The developer still knows the context of the changes they made. They still know how to fix it. They're still kind of in that mindset. We haven't put a lot of effort into fixing stuff or to doing work on stuff, so we're not doing a lot of rework on it if we'd have to pull something back. We haven't invested a ton of effort into it, right? And again, we're reacting proactively. We know things before it becomes a huge issue. If we start finding things out later, right, whether it's review inspection towards the end of the cycle, or stuff we're finding by a remote test group, or the final test group, or in this cases we just talked about, the security group finds some findings, right, that need to be fixed. Or worse, it's not even shown on this graph, is problems that are found by the users in production are by far the most expensive to fix. We have a lot of investment. We have to stop what we're doing to fix them if they're serious. We have to roll it through the entire pipeline that we just have to go back to the beginning on, as opposed to stuff that we just barely got into, right? So there's a lot of advantages of doing stuff earlier, right? And I think most people understand that pretty intuitively. But the key is to understand how important it is that if we can find the stuff via the quicker feedback cycles, then we are already closer to the beginning, right? All right. So that gives you all the background, and let's talk about some specific types of tests. And I'm going to go through each of the three stages I talked about, the commit stage, the acceptance stage, and the end game. I'm really going to spend times on the 2 on the end because most of you, I understand, are testers, right? And the quality focus is pretty easy to see. It's the other pieces where things get a little bit more interesting. So let's talk first about the commit stage, where we're code focused. Testing the code in the commit stage, like I said, this is code focused, developer centric. We're looking for rapid feedback. In the beginning, at least, of the commit stage, we want the developer to wait until things are complete. At least we want to time box it to something like 10 minutes so that they can be there, so they can sit there and watch it happen before getting up to get a cup of coffee and getting sidetracked talking to their buddy or getting sucked into a meeting or whatever the case may be. That's what they're trying to get in the commit stage. Now, again, the commit stage, it's not a hard and fast line. If you have a lot of unit tests or if you have static analysis, it's going to take a little while. Maybe you want to extend it past 10 minutes, but we want the developer to wait at least the 10 minutes, right? So he has some level of confidence that the code he's producing or she's producing is in good shape. And the types of activities that happen here, the continuous integration, like I said, we're going to compile, we're going to run unit tests, we're going to do static analysis, and maybe we'll do some dependency analysis, and I'll talk about those here. First off, unit testing. I'm only going to go through this one, I think, because I think it's so important because it forms the base for so much else that happens after it, okay? First thing to keep in mind, unit testing is not QA, right? This is a developer tool to see how the code's behaving. Is the code doing what the developer intended it to do? Not what it's supposed to do, which hopefully is the same thing, but what is the code supposed to be doing? Can we document what the behaviors are based on certain inputs, what outputs we're going to get, what's going to happen when we run this code, right? That's going to give us a lot of confidence that we can do fearless refactoring. And by that I mean I can go in later on as a developer and I can make changes to the way the code works, how it gets its job done, without changing its behavior. I can change from, hey, I was using a linked list before, I want to use an array list. I can go from, I want to use this particular algorithm to this algorithm. I can choose one library over another, right? And I can do those changes because I can rerun the unit tests and I can decide that, you know what? This code is still behaving the same way. I know that because I just ran the test again and they're still green. That's fearless refactoring. I can make any changes I want to the way the code works as long as I don't change the behavior. It's all internal to it. And this lets the developer get into the habit of code, refactor, test, code, refactor, test, right? I can get through that loop quickly, make sure I'm not breaking anything. Okay. And the way we normally see if we have enough unit tests is through code coverage. The problem, though, is code coverage is a tool. It's not a target, and often we use it as a target, or it's claimed as a target. Code coverage measures code executed while the unit tests are running. So if I run a line of code while the unit tests are going, that line is considered covered. It's not looking at how much I'm testing. It doesn't decide if I test anything, as a matter of fact. All it's doing is checking, am I running code? How much of that code am I running? So if it's not covered, I know that it's not tested. If it is covered, possibly it's tested. So really, code coverage tools are tools to find untested code, not to decide if I have quality code, right? Here's a couple examples of some open source ones, Emma, Jacoco, which are both Java tools. And Covers a .NET tool that has a freeware version, also has a commercial version. Those are great tools for finding untested code. Okay, so if I can't use that to determine, if I can't use code coverage really to find how the quality of the tests I'm writing, what can I use? And the answer is a type of test that you might not be used to, and that's called mutation testing. There's two popular packages out for Java and for .NET. There's plenty of options out there for Python. For Java, it's called PyTest. It's my favorite. For .NET, Ninja Turtles. Get it because it's mutation testing. Humbug for PHP. And what these types of tests do is they take your unit tests, which have to be passing, so it has to happen after unit tests are run, and it takes a copy of your code and it modifies it. Just pulls a copy of it aside and either gets rid of a line, changes the meaning of a line, and then it reruns the tests. And if the test still passed, then the code obviously wasn't tested. right? So what you're doing here is testing the quality of the tests. And here's an example. Let's say we had a really simple method, foo, and all it does is take an integer and it increments the value by 1 and then returns it, right? So if I write some unit tests, I give it an input of 4 and make sure I get back a response of 5. That's my unit test, right? But what a mutation tester will do is it'll take a look at that and it'll modify it, right? Maybe it will change it instead of increment it by 1, maybe it'll decrement it by 1. So now I put in 4, I'll get back a 3. If my tests all still pass after I've made that mutation, the mutation is considered to have survived, and that's a problem, right? I know I didn't have good enough unit tests around it. Do all sorts of different types of mutations. pytest.org has some great descriptions of the type of mutations they can do. This is a little bit slower than either doing regular unit testing or code coverage testing, but it's very, very valuable. It's well worth working in. If it was up to me, this would be on everybody's delivery pipeline. We would always do mutation testing. We'd just do it as part of the commit stage after the 10 minutes are up, because it might take a little bit longer to run. At least I'd run it every night or so, right, to give me an idea. What's the quality of the tests I'm running? All right, one other thing I would definitely make sure was in parts of my pipeline is static analysis tools. If you're not using static analysis, you're missing out on some really good free tools or free evaluation of your software. Static analysis tools are really good at detecting style issues. You know, you're using tabs or spaces or tabs, whatever it is that your standard is. Looking at duplicate code blocks. Do I have the same code in multiple places? A lot of these types of static analysis tools can even find, hey, you have the same code, the same loop somewhere else, it just uses different variables or different start and end points, right? It's all constants that could be replaced. Declared but unused variables, right? I declared int I, but I never used it. Did I intend to use it? Maybe I thought I had used it. Maybe it's just extraneous and doesn't need to be there. Confusing code. If not this, then else, right? Stuff that's kind of, you have to stop and think about it. Just all good code practices that can be applied. Some other things that the static analysis tools can find are things like race conditions, right, which are actually very, very difficult to find dynamically, but statically, through static analysis, can actually be found fairly readily. And this is where I'm trying to read values in one thread, read the same or modify the values in another thread, and find out that they're conflicting, right, and I get out of sync. The classic example for race conditions, I check the balance in my bank account, meanwhile another thread removes some money from my bank account, I go to remove the money and it's not there, right? That's a race condition. SQL injection, the most popular types of SQL injection can be found using static analysis, and even things like resource leaks. I opened a file but I forgot to close it. Right now I have to wait until my garbage collection comes around and closes that, or I'm just tying up file handles, stuff like that. All of this is important, right? And I don't want to downplay some of the earlier ones. The ones at the end are obviously easy to see, the race condition, SQL injection, resource leaks, why they're so important. But some of the stuff early on, confusing code, there's a list on Stack Overflow of funniest comments ever seen in source code, and one of them is a comment that says, when I wrote this, only God and I understood what I was doing. Now only God knows, right? Trying to maintain code that's confusing or that's hard to read can be really, really tough. So to keep maintainable code, to keep good code, static analysis is a great way to do it. Plus, if you're not having success with code reviews, static analysis is a great way to do the objective pieces of the code review, the stupid pieces about, hey, how much do I indent, where do I put my braces, the type of stuff that normally end up tying up all the time in code review sessions, and just makes those objective. It's done by the computer. You don't have to worry about it. There's different types of analysis tools for all different languages. SonarQube, it happens to be a fantastic open source product that will tie them all together and give you a great dashboard for quality on your code, right? That's the, since we're focused in the commit stage on code quality, right, we're code-centric, this SonarQube becomes a great tool for that as a dashboard of code quality. So I highly recommend it, open source. The last thing I'd always want to do in commit stage is checking my third-party components. OWASP has a list they come out with every couple of years called the OWASP Top 10, the Web Top 10. And in 2013, the last time it came out, one of the top 10 items that they saw as a security risk was using components with known vulnerabilities, right? That means you're using older tools, or I'm sorry, older libraries in your system, or even newer libraries in your system that have vulnerabilities that are known, right? Modern software is built so much on frameworks and third-party components that it's really important to know what you're putting into your system, and you don't want to put in tools and libraries that have known security vulnerabilities. So OS dependency check can run against .NET code, Node.js, Java, Python, Ruby. I think it's those 5 languages right now, and it can scan for any libraries that you're including, and just takes a look against the list of known vulnerabilities and just gives you a report of, hey, this one has this vulnerability. You have to make the decision as to whether or not that's something that applies to you or not, but you're using a tool that has that vulnerability, so you have to protect against it, remediate it somehow. If you do this early enough in your pipeline, right, especially here where we're looking at code, we're code-centric, we're looking at the code focus, gives you the opportunity to update proactively, right? You know what, I see that this version of Spring has some known vulnerabilities. I'm just going to upgrade to the newer version of Spring, see if they go away. If they do, great. Now I'm testing with it. It was an easy change. I don't have to do a big deal, right? As opposed to we're right before release, and now I need to start pulling out a major piece of my framework and have to hope it's not going to cause any problems. All right. So those are the types of tests I would do in the commit stage, the stuff that focuses on the code. The acceptance stage is where I'm going to focus on all my quality. And like I said, I don't want to spend too much time on this because I think most people understand the types of things that are going to go in here. This is your classic QA functions, right? We're quality focused. This is the bulk of the pipeline, and we are going to stay in this stage until we are confident that we have a viable candidate for production. All right? So we're going to look at functional tests, regression tests, acceptance tests, security, system integration tests, plus those extra pieces we talked about briefly and gave some examples of some security testing, some performance testing, some usability testing, maybe some manual testing, right? Things you can time box, things you can get just a good feel, so by the time I get to the end and I do the official test, I know I'm not going to be surprised, or I'm confident I'm not going to be surprised, right? And it doesn't mean just do one round of it, right? Maybe I can do some security testing early on, like I said, just through OWASP app, run my functional tests through that and just look at the report. But maybe I also want to do some harder scanning. Maybe I also want to do a couple other types of checks. Maybe I also want to get my one guy on the team or borrow somebody from the security team. Can you just take a quick look at this test, right? But I can spread that out throughout my acceptance stage, so I'm not holding everything up for that to happen, and I can arrange it so it's convenient for the entire process, so I'm not holding everything up. Some other things I would add that you may not have already thought about, obviously if you're doing continuous delivery, you're already doing some type of automated deployment, but really the importance of the automated deployments isn't so much that I have an automated installer. It's that I am getting repeatable, reliable deployments. Every time I run this, I know I'm going to get the same thing I got last time, or if I've made a change, I'm going to get what I just asked for. And that means by the time we get to the end and we do the deploy that really matters, the one into production, right, I can see, because I practiced this, I've used this in every environment up to that point, I can see that my deploys are going to work the same way they did before. No surprises. I'm not going to get to the end and find out, hey, you know what, we completely left out a step because I'm doing this everywhere the same way. One of the other things you'll find out using any of these types of tools, and some examples here, Packers for building images, Chef, Ansible, Puppet are all great tools for doing, they call them configuration management tools for doing installs and setting up configuration, making sure things are kept in compliance, kept up to date. The more automation you have around the deployments, the more reasons you'll find to deploy. The more excuses you'll say, you know what, I'd really like to do a demo, but the system we're using for testing right now is kind of in a mixed state. We got some stuff that I really need to get through, but let me stand up a stable version, or let me stand up an old version, the one that's in production, and show that on in a demo. or the next version, right? We're not quite ready through to push it out to production or push it out somewhere where people can see, but I can stand up a brand new box and use my automated deployment scripts really quickly and come up with a place to do the demo. So you will find more reasons to deploy. You'll go from having, why should I do a deploy, why should I do this, to why not? It's so easy. It's something that we don't need to hesitate doing. Along with automated testing or automated deployments, you do need smoke tests, all right? There is no sense in doing any other type of testing on the deployed system if we don't know that the deploy we just did was successful. So after every deploy, we need a quick feedback, testing the deployment, not the functionality. Did my deploy work? Right? Not is the app working the way it's supposed to, because this might be the first time I'm doing any testing on it, but I did the deploy work? Did the system come up right? Right? Focus on the basic signs of life. Is it running? Is it responding? Check my interfaces between the systems. Is my web server talking to my database server, right? Stuff that needs to be set in the configuration settings. Can I log into the database server? Can my web server log into the database server? Can I log into the system? Am I using the right values, right? Am I seeing the right stuff? Right, so how many times have you found all sorts of bugs when you first get a system to test? You wonder how this code ever got out of development because it's so bad, nothing seems to be working. You spend a couple hours writing up your report, send it back to developers, and you find, oh wait, you know what, we had an extra deployment value or an extra configuration value that we forgot to tell you about. If you set that, all this gets cleared up, right? You wasted all that time testing what was really just a defective deploy, right? So having smoke testing, very, very valuable, especially once you get into having automated deploys. Now I will say, even if you don't have automated deploys, you're still going to want some smoke tests, right? You still do them anyway, it's just an automatic, right? I do my deploy manually, and then I check to see if it's working, right? That's all the smoke tests are. But if you can automate them, you have a huge tool that you can use over and over. All right, like I said, I didn't want to spend much time on all the other types of testing that normally happens during acceptance because I think they're pretty well known. But let's jump into some of the end game, some of the other stuff that you might want to do. The end game is where we get delivery focused, right? These are the steps that are only going to get done when we're releasing. They're the ones that are too expensive to do on every build, whether because of time, because of resource, because of the effort involved, the people that are needed, the specialized equipment, specialized tools, whatever it is. You're not going to start the end game until you're confident that you won't be surprised. It doesn't mean you won't be surprised, but you have a high level of confidence, right? Surprises should be the exception, not the rule. We shouldn't always get to the end and say, oh, yep, got the security test at the end again, and we're failing, right? If that's happening, then that's something, definitely an indication that you should be going back and adding some security testing earlier on. Or if we always get to the end and we're not meeting our performance requirements, well, that's an indication we should put a little bit of performance testing earlier on. This should be a double check. This should just be a verification. This should be checking the box that says, yep, we did the official test that you needed us to do, and here's this is just providing us evidence that what we thought all along is true, right? We've already done enough of that type of testing to see that we're not getting surprised at the end. And so some of the types of tests, like we went through most of them, one of the things I do want to talk about here is non-functional tests. I'm not going to read through this whole thing. Non-functional tests are all the illities, the stuff that's often subjective, open to interpretation, or needs to be evaluated. The stuff that's hard to put real hard and fast numbers and make an automated check. So this type of stuff normally happens towards the end. These don't map to functional requirements. They often need to be tested on a production-like system, right, or an entire system. So it often doesn't suit itself well to doing earlier on. So a lot of the non-functional testing will get pushed to the end, and that's fine. We want, again, we don't want to be surprised by any of this, so if there's anything that we can do a little bit earlier, anything that will give us a little bit of an idea that we're not going to fail, a little bit of confidence that we're not going to fail when we run these at the end, that we're not going to be surprised, then those are valuable to do earlier on. But a lot of this stuff will wait towards the end. The other thing to consider doing when we get towards the end game is we can start doing things in parallel, right? We'd like to run a lot of our testing in parallel so it gets done quicker, right? Shorter elapsed time. The problem is that we don't get feedback between the tests. So if one of those paths that we're doing in parallel is failing, we're going to waste a lot of time doing the other types of tests, and maybe we have to wait until they all come back before we can kick the thing back to the beginning and find out. So what we want to do is try to wait until the end, and we should have an expectation that stuff we're doing in parallel should pass or will pass, right? Again, no surprises. All right. Finally, just a little summary here. Right, what we're trying to balance is early rapid feedback versus no late surprises. We want to focus on doing just enough of each type of testing earlier in the pipeline to determine if further testing is justified. And we're going to move our stuff through. We're going to start out laying stuff out so that we're focused early on the code focused, right? That's the stuff we can do with really rapid feedback. Move through into time when we're quality focused, determining do we have a viable candidate for production, right? That's going to be the bulk of our process. And at the end, the stuff that's truly delivery focused, right? Not I'm checking the quality at the end, but this is the stuff that the boxes I need to check, the documentation I need to provide, the packaging I need to do, the stuff that has to wait to the end, right? No surprises at the end, rapid feedback at the beginning. And that's it. Any questions?
Hi, Gene. We have a couple questions for you. First, I would just like to ask, how do you recommend getting upper management to buy into testing in a continuous delivery pipeline?
All right, so getting the buy-in is important, obviously, especially if you're trying to adopt a plan to move to continuous delivery or DevOps. My first advice is, if that's your goal, is to get to DevOps, don't do it. What you should be looking at is, how can I improve my process? Okay, and if we went back to earlier on, let me see if I can flip to that slide real quick, to our value stream. This gives us some idea of where we're spending, right, where our bottlenecks are. Rather than trying to say, I want to buy into improving the pipeline as a whole, just pick one of these as a roadblock. I spend, let's see in that picture there, functional testing happens overnight, right? There's a line in there that's, let's see if I can show it here. Yeah, there. Oops. Oh, sorry there. There's a line in here where it says functional testing is an overnight thing. It takes overnight to run it, right? Well, if I say, you know what, I'm always waiting, I'm always finding problems the next morning, it'd be really nice if I could do some functional testing so that I didn't have to wait for that whole run, right? So focus on that. Sell that to your management. Say, hey, I just want to make it so I have a little bit more rapid feedback. And in return for doing a little bit of a quick functional test here, I can push some other things down further and have higher confidence in them, even though they're later in the pipeline. And if you just keep knocking out the problems and the roadblocks and the bottlenecks one by one, you'll find that you actually do have a move towards a faster, better, quicker, more valuable pipeline, and you are getting towards continuous delivery and DevOps. If you ever get a chance to read the book, it's a novel by Gene Kim and a couple others called The Phoenix Project. One of the things I really like about that, we push that in all our DevOps courses, is that they didn't set out to get to a better pipeline. They didn't set out to get to continuous delivery or DevOps. All they were trying to do in that book, it's a novel about a guy who gets thrown into a problematic process and he just fixes the first problem, and he finds there's two behind that, and he fixes those two problems and finds there's a couple behind that, and he starts looking at systematically, where are our bottlenecks, what's slowing us down, what problems do I really need to solve so I can get better. So summary, the way I'd approach it to get people to get buy-in from upper management is just address roadblock by roadblock, right? Here's how we're going to make our system a little bit better. Here's how things are going to get a little bit better if we fix this, if we address this, and eventually you'll find that you're getting more and more free reign and more confidence in the changes you're making, and that they start buying in without you having to ask for it.
Awesome, that was great. I have another question here for you. What are the risks, problems that are encountered if manual testing is performed towards the end of the delivery pipeline?
Right, and so this is what we talked about through a lot of them, just whether it's manual testing or the security testing, the performance testing. If you wait for anything, the first time you do it is the full-blown at the end, then you could be surprised, right? And anytime you get a surprise at the end, that means you're going all the way back to the drawing board. You're being very reactive, right? The graph we showed of the cost, whether it's in time, resources, effort, for finding stuff later in the game, right? It goes way up if you find it late. So if we can do just enough of manual testing in this case early on to say, you know what, I'm pretty confident that I am not going to find any problems at the end. Well, now I have some advantages over the people that waited to do it till the very end, because I can do it in my test cycle. I don't have to start all the way from the beginning to decide, do I have any confidence here, right?
Okay. Okay. I have another question here. It says, do QA folks need to invest in learning deploy tools like Ansible, Puppet, Chef?
So those tools are great to have. Typically on the teams we go into when we're trying to do a DevOps transformation or trying to teach people how to improve their process, and we're bringing in things like automated deployments, we'll bring in somebody that really knows those tools, and they'll teach the rest of the developers and the ops people. The testers generally don't have to know how to write that code, with two exceptions. One is they need to know how to run it, right? Because they're going to be the people that use it. Like I said, the acceptance stage is the longest piece of of the pipeline, and the QA folks are the people that are generally doing most of the work there. So they'll need to use it a lot. The other thing is that the automated deploys are code, right? That's the whole goal. Code is infrastructure, and so those tools will need to be tested. Like I said, smoke tests are the first step in testing an automated deploy. So just like you'd need some people that have some familiarity maybe with Java, if you're doing a Java app in your QA department, it's not that they need to know it, but they should be familiar with how it works and what it does. And that's important whether you're talking about application code or deployment code.
Okay, I have another question here. It says for parallel testing, when you say this, how much do we need to scale or spread out the area of testing? Multiple browsers, versions of browsers, M sites, mobile devices, including iOS and Android. Is there a limit, and how are we going to do this?
Yeah, so, well, first of all, when I'm talking about parallel testing, I was really talking about different types of testing that are happening, but certainly that's a good example. If you're trying to do parallel testing so that you're not doing a single-threaded functional test across every different combination of browser and OS and mobile application, mobile device, and that type of thing, there's certainly a lot of opportunities to do parallel testing within those types. A great example is using some of the apps. If you use Selenium to do your testing on your regular project internally, with some very, very small changes, really just a driver change and entering a couple of configuration options, you can send that Selenium test to someplace like Sauce Labs, who can run that test over a whole list of different browser types, mobile devices, OS versions, and do all of that in parallel. So my advice for that type of parallelization is do as much as humanly possible. It's going to need to wait till a point in your pipeline where you can make your code available to the provider, in this case Sauce Labs. They're going to use browsers on their environment to hit yours. So you're going to need to open up a hole in your firewall, or they actually have a product that will let you do a VPN between them that they can set up for you. And that will give you an ability to do a lot of testing. So that's for functional tests, functional and regression type tests. There's also tools like LoadStorm, which is very similar. It actually works very much like Sauce Lab works for Selenium. LoadStorm works the same way for JMeter. So in that case, you're not really trying to hit it with different OSs or anything. LoadStorm is really designed to hit you from a lot of different locations and hit you at rates that you couldn't internally generate yourself, although Sauce Labs, for that matter, can actually do a lot of that type of testing as well.
Awesome. We have one last question here, and I was just asking, what about Jenkins? They noticed that you didn't mention it during the presentation.
Yeah, so I didn't want to get so much into the tools. I mentioned a couple of them where I was talking about types of testing you might not be used to. But for me, we use Jenkins on every project we work on. We actually have a product called Secure CI, which is a collection of a lot of the tools I've mentioned, built around Jenkins and a bunch of other open source tools. And we package into a VM or an AMI so we can get started. So when we go into a place, we can get started on a project right away without having to do all that setup that normally you'd spend the first couple days or first couple weeks trying to get all in place and getting them wired, and it's the same thing time and time again. But Jenkins is really the key for a lot of this. If you are spending time doing automation, you need something that drives it all. And the pipeline that I showed you, a lot of times that can be run really through Jenkins to have Jenkins move the stuff through the stage gates. And the commit stage, like I said, that's really CI. That's the focus of the commit stage is going to be the same as the focus of CI. You know, Jenkins is really going to be the thing that drives that. But even beyond that, getting through the acceptance stage, running your Selenium tests, your Cucumber acceptance test, kicking off your scans, your security scans, and your JMeter tests and all that can all be done through Jenkins. So we would use Jenkins to run all of this.
Awesome. And so we're actually at the end of our time here. If you guys have any other questions, you can email them to Gene directly. Gene, I've got my screen closed. Is your okay? Perfect. Email showing up there.
Yep.
You know, lastly, I just want to thank you for a wonderful presentation and thank the attendees today. You know, QA Source offers a weekly free blog on blog.qasource.com. You will find topics on automation testing, manual testing, mobile testing, performance testing, and best practices for managing your QA team. Gene, did you have anything else you want to throw in there before we close this up today?
No, just thanks a lot for letting me get an opportunity to talk. I hope this was useful to some of you, and if you have any other questions, anything you think of, please feel free to shoot me an email or tweet at me, Coveros Gene. I'll be happy to get in touch with you and talk about it further.
Awesome. Thanks, Gene.
Thank you very much.